This lesson is all about elements that need to be refined in order to be useful to us as a human population. The two objectives that go along with this section are to describe how the density of gold allows it to be panned, and also to describe how copper and iron are extracted from other ores. So what we're really doing in section 4 is we're putting all the other pieces from chapter 1 together. We're talking about those characteristic properties from section 1. We're talking about some of the unique properties of matter that we discussed in section 2 and the ways that we measure those properties. And then we're taking just a little bit about what we learned about positive and negative charges inside an atom from section 3, and we're applying it to life as we know it today. Density, gold, copper, iron, all of these are terms that we see applied in our daily lives. So density is a characteristic property for many different pieces of matter, gold included. Remember that a characteristic property is one that you can use to set a type of matter apart from other matter that exists around it. Density is a characteristic property of matter or of gold because gold is really, really dense. If you look there on the screen, you'll notice that gold has a density of 19.3 grams per cubic centimeters. Now remember that label, grams per cubic centimeters, comes from the formula for calculating density, mass divided by volume. Grams is a mass measurement and cubic centimeters is a volume measurement. So the density of gold is really impressively high. It's quite a lot more dense than the other objects or types of matter that you're going to find around gold if you go digging for it out in your backyard. So for instance, gold is a lot more dense than sand. It's a lot more dense than dirt. It's actually a lot more dense than its fake counterpart, pyrite, as well. Pyrite is known by another name. Most of the time it's called fool's gold, and this mineral has a density of only 5 grams per cubic centimeters. So if you find something golden shiny in your backyard when you go panning, as I'm sure this lesson will inspire you to do, you can tell if it's gold or pyrite by its density. In order to separate gold from surrounding minerals, there's about a 5-step process that you would follow. The first thing that you need to do is take a mixture that you hope contains gold dust as well as sand and dirt particles and place it in a shallow pan. You're going to cover the mixture with water and then swirl that water around in the pan, allowing it to pick up and to dissolve to form a solution with some of the dirt particles and the sand particles in the water. Also, the water is acting as sort of like a chemical form or a mechanical form of erosion. And so it's picking it up and it's moving it around. Because gold is really dense and sand and dirt are not, when you pour off that water, you're going to end up losing a lot of the sand and dirt particles that were floating near the surface. The gold particles, however, are going to settle out on the bottom, so when you repeat this process over and over and over again, eventually all you'll be left with are those more dense gold particles. Now, this isn't the way that the gold industry operates today with single pans. They use huge pieces of machinery called dredges, but those dredges work in much the same way. You have a huge container that you put all of these mixtures, water, sand, dirt, gold dust, all that stuff together in, and it's basically just swirled around, and the gold sinks to the bottom, and the sand and the dirt is going to be eliminated with the water off at the top. Copper is another important metal, and copper is unique because unlike gold, it doesn't exist in its pure form out in the natural world. Most of the time, we find copper existing as a compound. Remember that a compound is a combination of different elements to form something with new properties. We call a compound, when we're talking about it in the context of metal, we call it an ore. Ore is just a rock that has metal and something else. That could be two metals combined, that could be a metal and a non-metal combined. But the key is that one of those metals involved in an ore is economically useful. It's something that we use in industry, it's profitable. So in order to extract copper from a compound form, from an ore, we have to take advantage of yet another characteristic property. In this case, we're dealing with chemical activity. It just so happens that when copper is exposed to electricity, something really unique happens. This process of exposing copper to electricity is called electrolysis. You're actually going to get to see this modeled tomorrow, or on Friday rather, so hang in there for that. But electrolysis allows us to separate copper from other materials. Basically, what happens is a battery or some other source of an electric current is going to send those currents over wires to little metal strips, which we call electrodes. The electrodes are going to be dipped in or sitting in a water solution that has some copper ore in it, and all the other substances, elements that are combined to that copper. When the current's turned on, one electrode is going to sort of act as a magnet to catch the pure copper from the solution, and the other the other electrode is going to sort of act like a magnet to catch all the other stuff. And so because the electricity is being run through those wires to the electrodes, we're able to separate the pure copper from all those other substances. Just like the gold industry uses a version of panning in order to find gold today, the copper industry uses a large-scale process of electrolysis in order to produce large quantities of the pure copper mineral that we see in use today. Iron is yet another important ore that exists in nature. Oftentimes, iron is going to be chemically combined with oxygen in ore form. And because of this, we can take advantage of kind of a neat characteristic property, which has to do with heat. So when iron is exposed to a super hot fire, it's going to separate from all of the other pieces of ore that exist or the other substances that exist around it. Blast furnaces are sort of the modern way of separating iron from ore. And a blast furnace is just a really, really hot oven or stove. They use a material called coke to burn to a really high heat in these blast furnaces. And when iron ore is put into the blast furnace, it's separated from all of the impurities. The reason that this purified iron is so important is because it's a main ingredient in steel, which we know is used in all sorts of contexts. It's used in building. Oftentimes it's used in other forms of technology and industry too. So you'll notice that there's a video on this slide. There's also a video on the second slide. I'll post links to those videos on my website so you can watch them later on. And that is the end of section 4. You have 2 assignments to be working on before Friday. The first is the notes for this section. Those will be due at 2 p.m. to the Dropbox. There's also a homework form attached today to our website, and that will be due on Friday at 2 p.m. as well.